因为 Android 我上个礼拜
这样
在想啊，可以去了。
So I'm going to start now. So today we focus on Bernoulli's equation. So I'm writing something to you now. So
now
number one,
可以哦。
the Bernoulli's equation we can apply in any streamline. Alright? So for example, it should be any streamline. Okay? Any of these streamlines. Okay? So now, for example, I can choose any point here, right? Any point here. In both cases, we can apply the Bernoulli's equation between point 1 and point 2. In that case, the fluid must be the same type of fluid. Same fluid. Then I can write P1 by rho g, V1 square by 2g, Z1, P2 by rho g, P2 square by rho 2g, Z2, right? So P1 by rho g, V1 square by 2g plus Z1. So this is energy, total energy at point 1. And at point 2, total energy P2 by rho g, V2 square by 2g, Z2. So P1 by rho g is pressure head, V1 square by 2g is velocity head, and Z1 is elevation. Okay? And unit both sides, P1 by rho g unit is meter, V1 square by 2g unit is meter, Z1 is meter. Okay?
有分单位都没有分。
Okay, this is one equation. Number 2 is continuity equation. That means, you know, because this is liquid, this is valid in liquid fluid. Right? Liquid is flowing. In that case, we can apply this. So in that case, the volumetric flow rate at state 1 and the volumetric flow rate at point 2 or state 2 are same. Q indicates the volumetric flow rate. Right? Volumetric flow. And its unit is meter cube per second. That means the volumetric flow rate at state 1 and state 2 are same. At that point, the volumetric flow rate, and at that point, volumetric flow rate are same. Okay? This point, that point, all points, the volumetric flow rate are same. Okay, and you also remember Q, I can say, Q is defined by A times B, cross-sectional area times velocity. Then I can write A1, B1, A2, B2, right? A indicates the cross-sectional area, unit is meter square. And V1 is the velocity, its unit is meter per second. Okay, so you can see at that point, if the cross-sectional area of the flow are same, right? In that case, I can say the velocity at every points are same, right? No problem. If the cross-sectional area are different, this means that the velocity at all points are different, right? But volumetric flow rate are same. But this one may be different. Okay, so these are the equations. So how many equations we can see here? Only 2 equations, right? In the fluid mechanics, there are 3 equations. One is how to calculate the pressure, right? Force, you know, same from pressure, and Bernoulli's equation and continuity equations. Only 3 equations. All right? And we are applying also some basic idea. Number 1 is, right? Rho g is equivalent to gamma, right? We know, right? Then we can also say rho of water times g is specific gravity of specific weight of water, right? So rho g becomes specific gravity times gamma w, right? Same thing. I taught you this thing in my first lesson, right? So specific gravity is equivalent to density of fluid to density of water. All right. So we are using all this concept for today's tutorial questions, which are quite easy actually, not too difficult. Today's tutorial is quite okay. You have to apply the Bernoulli's equation of state plus the continuity equation. So water flows through the pipe. You can see, so water is flowing through the pipe reducer. This is a pipe reducer, right? That means at that point diameter are different, right? Not same, correct? So cross-sectional area at every points are different. So the velocity at every points are different, right? But the volumetric flow rate at all points are same. Mass flow rate at all points are same. No difference. Okay. So life is quite easy now. So water flows through the pipe reducer as shown in this figure, determining the flow rate Q. You have to find the value of Q. That's all, right? Of the smaller pipe, D 0.05. So at that point, what is the volumetric flow rate? What could be the flow rate if the gasoline is the working fluid? So working fluid may be anything. Gasoline, water, mercury, anything. What would be the flow rate if gasoline is the working fluid? Specific gravity is not given here. So Q I can easily calculate, right? So what is the value of Q? A times velocity, right? I can find Q at the point and Q at the point are same, right? So if I find Q at the point is enough, correct? So what I can write? They tell me you have to find the value of Q, and I tell you, so this is 1, I can tell you, and this is number 2. So I can say Q equals to cross-sectional area times velocity. So I am using this equation. So where is the streamline? Streamline, right? Agree on that? Streamline, right? Streamline. This is this way, right? Correct. So I can apply Bernoulli's equation in any of these lines, right? No problem. I can put number 1 is here, number 2 is here, okay. I can put number 1 here, number 2 here, no problem. I can put anywhere. But you should choose 2 points, inlet and outlet, or you can use Bernoulli's equation at 2 points. You should choose that 2 points very carefully. Where is the best point? If I choose here, I know the distance from here to here? I don't know, right? If I choose at that point, maybe okay, I know the distance. Not bad. If I choose here, maybe better, right? I know the distance from here to here. Right? If I choose the point here, yeah, this point plus here, I can calculate. So if I choose the point here, can not so nice, right? If I choose that point, can, but quite complicated. If I choose at that point, I can do this, but complicated. Because at that point, I do not know the velocity. Right? At that point, I also do not know the velocity. Correct? I need to find the value of velocity, which is important. Okay, if I choose the point at here, is good or bad? Why?
Velocity 0.
Why? Velocity 0 here? Stagnation point. Stagnation point. Okay, for example, okay, if I flow air at that point, right? You see, take a look. Fluid flow is coming this way and correct? Shift. At that point, right? The velocity doesn't touch at that point. The flow doesn't touch at the tip of this point. So it comes here, then flows. Comes here, flows. Similar to here. So this point is very narrow, very sharp. So at that point, the flow doesn't touch. It goes here, then shifts this way. Comes here, goes this way. Okay, this point is called stagnation. At that point, the velocity is zero because no flow. Right? But at that point, I can calculate the velocity. So that's why I choose the half, right? For example, from here to here is 0.1. I choose from here to here, right? Some number I choose from here to here, right? So I can take the distance from here to here, right? I choose number 1. And from here to here, I choose number 2 at the stagnation point. So this is 1, this is 2. Right or wrong? Right. Then I can apply Bernoulli's equation between point 1 and 2. No problem. I can use it. So, how I can use it? You take a look. I write very carefully. So I can write P1 by rho g plus V1 squared by 2g plus Z1 is equivalent to P2 by rho g, because of same fluid, that's why rho g, same, I didn't change, plus V2 squared by 2g plus Z2. Can I do this? No problem. So here, same line, right? 1 and 2 are found in the same line, so there is no change in potential energy, right? Or elevation height, 0. So velocity V2 is 0, right? Because of stagnation point, velocity is 0. And P1 and P2, there is. Because I can measure P1 here. No problem. Can I measure? Rho GH. Right? At that point, pressure 2, rho GH. Correct. So pressure 1 and pressure 2 I can measure, no problem. So V1 I can find. So what I can do here, so I can write V1 squared by 2g is equivalent to P2 minus P1 by rho g. I can write this, right? So now, what is P2? Tell me, what is the value of P2? I assume the distance from this line to this line, right, is y. I can write any number. No problem. Then I can write, what is P2? Tell me. Rho g 0.2 plus y. Am I right? What is P1? Rho g y by rho g. Then I can write rho g is 0.2, right? So this value is rho g cancel, and I can write 0.2. So V1, am I right? 2 times g is 9.8, 0.2. I can get the answer 1.98, right? Meter per second. You can check the calculator, I can do this. You understand what is this point? I can measure the pressure. Right? Experimentally I can measure, no problem. Okay? Not calculation, I can experimentally measure. Very easy. And here also I can measure the pressure. The distance from here to here is 1, y plus 0.2, pressure P2. And P1 is here, right? Y plus rho g. So rho g times y is cancelled from both sides. I can get rho g times 0.2, rho g cancel, I can get 0.2. So V1 becomes rho 2 times g 9.8, 0.2, I can get 1.98. Right, very simple. So what is the Q? What is the value of Q? Tell me. Q becomes,
Yeah, you wash the left.
what is the value of Q? Tell me.
You wash for me.
This color, right? Q
You
becomes
derive the whole thing.
A1, V1. V1 I know. What is A1? Pi by 4. V1 is 0.1, right? 0.1. 0.1 squared. This is A1. V1 is 1.98. So volumetric flow rate I get here 0.0156 meter cube per second. Yes? Very simple. So at that point they tell you, if the diameter was smaller, pi d is 0.05, what would be the flow rate if the gasoline is the working fluid? What is the flow rate here? What is the volumetric flow rate?
Same.
Exactly same. I tell you, Q at every points are same. So I can write Q at the exit is same value. Okay? Now my another question. Can you find the velocity at the exit? How? A2 V2. A2 I know. Pi by 4 0.05 square. And Q is this value, right? Then I can calculate. Okay, so this is the extra question. Calculate the velocity at the exit. Can I write here? I can write for you. Extra question, right? Find the velocity at the exit.
How you know the stack? Because
Find the velocity.
the picture, right? Like they show you like means the this one is fixed already. Means here 0 there. Like no more. If this is not 0, the thing will keep increasing, right? But the thing, if the water flow,
Done, right?
Stop flowing yet.
yeah, all the questions show is stop flowing already.
Looks easy, right? Not difficult.
Unless they say like it's still keep moving up lah. Then
Alright.
assume here 0. Stagnant.
There is no
Alright.
water flowing.
So here actually I show.
Wash left.
Okay, I show you the solution here in another one, right? I tell you at the point what is the VXC. So how you can calculate VXC? Q becomes A1 V1, A2 V2, right? So Q becomes I get 0.0156, A2 is pi by 4, this diameter, right? 0.05. 0.05 square times V exit. This is V exit, right? V, you can write V exit E. Then VE, you can find no problem. Alright. At the point, what is the exit? We can do it. Okay. Water of constant depth gauge flows from a large tank through 3 pipes of different diameter of pipes with different diameters and inclination as shown in the figure. Viscous effects are negligible. Determine the height H1, H2 and H3 in terms of H. Alright? So this one I think all of you can solve this. So in the question, what is the understanding? Very simple question, but understanding is important. So same fluid, right? So what is the streamline? Streamline, right? Another one? No problem. Another one, no problem, right? So at that point, what is the pressure? Atmospheric pressure, right? At that point, what is the pressure? Atmospheric pressure. Here, same pressure, atmospheric pressure. Atmospheric pressure, atmospheric pressure. Atmospheric pressure, atmospheric pressure. No problem. Okay, my question is now, what is the velocity at that point? 0, right? Because the fluid level doesn't move, fixed level. Right? In the question I see it is fixed level, it doesn't move. So velocity is 0. So at that point, what is the velocity? Definitely 0 because the water level doesn't move up, right? 0. At that point, definitely 0. So at that point, velocity 0? Sure. 0? No, why? Because there is a vertical, horizontal component. There is no vertical component, but there is horizontal. It is present because it is moving in this direction. So at that point, there is velocity. Definitely here. Here, yes. Here, yes. Alright? This is the concept. I know what is the pressure, what is the velocity. Now I can apply Bernoulli's equation. Very good. I can apply Bernoulli's equation between here and here, no problem. Here and here, same. Here and here, yes. Then you can solve it. So at that point, I have to choose the reference point. Number 1 is reference line. So if I choose this is the reference line, this is nice. Why? Because I can measure anything from that reference point. From here to here, h. From here to here, h1. Here to here is 2. Here to here is 3. No problem. So before solving the question, I do a reference line. That reference line. Now I can choose the points. I can choose this is 0, this is 1, 2, 3, 4. I can choose anything, right? No problem. Right? So now I show you the point here. So this is the reference point. This is the reference line. I choose this is 0 point. So at that point is 1, at that point is 2, at that point is 3, at that point is 4. Alright, 4 on at point. This one. No problem, right? Then I write here at point 0, 1, 2, 3, 4. Atmospheric pressure. All pressure equivalent to atmospheric pressure. Then V0, V1, V2, velocity is 0, right? So I can do Bernoulli's equation between 0 and 1. No problem. Then I show you, I can apply Bernoulli's equation between 0 and 1. So what I can see, P1 and P2, we can cancel, right? Same pressure. V0 and V1, 0 velocity, 0. So Z1 and Z0 are same, right? Correct. So this means that what is Z0? The distance from here to here is Z0, right? From here to here is Z1. From here to here is Z2, right? From here to here is Z3. So I can write H1 becomes H. This is the answer. Then you can see I can cancel. Then I can say H becomes H1 because Z0 becomes Z1. The distance from here to here Z0, here to here Z1, here to here Z2, Z3. Because these are reference. I can measure everything from here. What is Z4? Z4? So I can write Z4 that's why I can write H becomes H1 or H1 is equivalent to H. This is the answer. So number 2, I can apply Bernoulli's equation between 0 and 2. Easy. Right? Then I can write P0, I write here gamma, right? Or you can write rho g and gamma same. So P1 not and P1 2 cancel. This one cancel. So Z0 becomes Z2. So H2 becomes H. This is the answer. Then I can do this one. Then I can write H becomes H2 because Z Z2 or Z0 becomes Z2, or I can write H2 becomes H. This answer. Okay. Number one is understanding, and after that, how to apply the equations between two points. Right? Because at 0 and 1, energy are same. At 1 and 2, energy are same. 2 and 3, energy are same. So that's why I can write any method. If you write 1 and 2, yes, you can solve. 2 and 3, yes, you can solve. 0 and 3, yes, you can solve. 4 and 3, yes, you can solve. No problem. But you choose the points carefully. Right? So that's why you should do more practice. Without practicing, it's very difficult. Right? In the exam hall, you get how many hours? 2.5 hours, right? Not more than that. So you think how to answer quickly. Alright, so now I go to between 0 and 4. I tell you, right? I can choose 0 and 4. If I choose 0 and 4, I can write P0 by gamma, B0 square by 2g, Z0, P4 by gamma, Z4 by 2g, Z4, right? So P0 and P4, same, right? I can cancel atmospheric pressure. So B0 is 0, bye-bye. Z0 is equivalent to H. This is 0. V4 is not 0, right? V4 is not equivalent to 0. So Z4, 0. I tell you. Then I can write this one, right? Now I can write Z0. That means V4 square by 2g equal to H. So I can write V4 becomes root over 2gh. Right. Now can you tell me what is the value of V3? Tell me. What is the value of V3? V4 is this direction, right? You take a look. V4, right? V4, right? And V3 is in this direction, am I right? Correct. And this angle is 45-degree angle. So this is also 45 angle. So V3 becomes V4 cos theta, right? I can write. So mathematically I can write V3 becomes V4 cos 45 degree. Theta is 45 degree because of horizontal component. Right? Then what is cos 45 degree? V4 is 2gh. Cos 45 is 1 by root 2. Right? So now I'm going to substitute the number. Then I can do this here also, no problem. V3 becomes, V4 is 2gh. Cos 45 is 1 over root 2. Am I right? Then V3 becomes gh. Right, cos 45 is 1 over root 2 and 2gh, so root over gh is P3. Answer. Then between 3 and 4, because I know velocity, P4 and P3 cancel. V4 I know, V3 I know, Z4 is 0, Z3 is H3. Now I am going to substitute the number. I can finally get the value of Z3, which is H3. Alright, now I can show you, I can cancel them, right? No problem. That means P4 and P3 are same, atmospheric pressure, they can cancel each other. V4 is not 0, V3 is not 0, Z4 is 0, right? Because it is in the reference line. That's why it is 0. Then I can find H3 is equivalent to the distance from reference line to this point. Then I can get Z3. Now see, life is easy. V4 square, you see. So this value is root over GH, right? I calculated before already. So this one I know, this one I know, right? So I can do it easily now. So what is V4? 2GH, right? What is V3? GH. 2G. This is Z3 is H3, right? So no need to do all the calculation. So this one is GH by 2G, H3 becomes H3. Easy to calculate. No need to do all this. Right? From the previous slide, I know, right? Root over 2GH square, right? GH, then GH, this one cancel, is good. Alright? Understand or not? Because this is question. But in the exam hall, this is not coming. Okay? Quite complicated. These are very, very easy. It is not coming. Just for you to understand. Okay. As shown in this figure, determine the height H. They tell you what is this value and pressure inside the horizontal pipe at that point. When the nozzle exit is at the same level as the oil water interface, that means this value doesn't change. It's always fixed. Okay? So what you do, you have to find the value of H and the pressure at this point. How to solve? You think how to solve? Streamline, right? Oil. I forget about oil. I thinking about water. Water is flowing this direction. Okay, I can choose my first point is here. 1, right? I can choose 1 is here, number 2 is here, number 3 is here, number 4 is here. Right? Then I can find the value of H. How? You can find the value of H. You have to do Bernoulli's equation between this point and that point. Then you can find. And you have to do the, what is the reference line? Reference line should be here. Easy to calculate. If you do the reference line from here to here, Z1 is here, correct. Z2 is here to here, right? So Z1 is 0, but Z2 is H. Then I can calculate. So now I show you, I apply, this one is 1, at that point is number 2, here is number 3, here is number 4, right? This point is number 4. Can you tell me pressure P2, right? Pressure P1. Here is pressure P1, right? What is the value of pressure P1? Tell me. P1 becomes, atmospheric pressure is 0, specific gravity of oil, rho g of water, H is 4. Am I right? Very simple. This is rho water G. This one, rho G is here. I can calculate P1. What is P2? 0, right? P2 is atmospheric pressure. We consider the gauge pressure. So this is 0. Here if I write P naught plus this number is the absolute pressure, right? P naught, P atmospheric pressure we consider 0 as gauge pressure. So this is the P1 and P2 here is obviously 0, right? Very good. I can write 0, no problem. P2, I can write 0, no problem, right? So what is the velocity V1? Velocity here, V1, because
0.
they are not moving.
0.
0. Then I can write V1, wow, very, very simple. Never mind. So this is 1. This is number 2. This is number 3 at that point, right? This one is 4. So P1 I can write. P1 becomes specific gravity of oil, rho g times 4, right? And P2 I can write 0. What is the V2? V1 is 0, right? What is the V2?
0.
0. So what is Z1? Tell me.
0.
Z1 is 0, right? What is Z2? H. Correct. Now I can solve easily. So what about the 3? P3, 0, right? P3 is 0. V3? No. Z3? 0. Same reference line. So I can write all these. P3, 0. V3, no. Right? This is not 0. Not 0. Z3, 0. Correct. So what is P4? P4 is not 0. V4 not 0. What is Z4? Z4?
9.
The distance from here to here is 2 meter, right? From here to here is 1 meter. From here to here is 1 meter, right? Going downward is minus 1 meter. Then I can write Z4 is always minus 1. Okay, I choose everything here. Now I do the Bernoulli's equation between 1 and 2, 1 and 3, 3 and 4, whatever I can do. Right? Because I choose everything here. Then I can do the continuity equation between 4 and 3 in order to find the relationship between velocity V4 and V3. Done. Alright? So my question is solved. Now I show you here. I choose this is number 1 point, this is 2, this is 3, this is 4. 4 is not here, it is here. 4, okay? 3 is here, 2 is here, 1 is here. Okay? Then I am going to write h equals to, I get this 2.8. How? I give you the answer, but how? You have to write P1 by rho g plus P1 square by 2 plus Z1, 1 and 2. I do Bernoulli's equation between 1 and 2. Then I can write P2 by rho g P2 square by 2g plus Z2. What I can write? Tell me. So P1 there is some number, right? P2 0. V1 square, V1 0, right? V2 also by by. Then Z1 also by by, right? Then P1, what is the value of P1? You remember? Tell me. 0.7 times kg of water times 4, right? By rho g. And Z2 becomes H. Am I right? Then, oh, life is very easy now. Just cancel 2.8, right? Then I get H becomes 2.8. Done. So H first question is solved, right? First question is solved. This answer. Second question. To tell me what is the pressure at P4? How do you get it? How? Which one is good for you? You to think how? I know V3 I do not know, V4 I do not know, right? But I know the relationship between V3 and V4. I know. So between 3 and 4, because I'll show you here, right? This is 4, this is 3. So I can write Q is A3, P3, A4, P4, right? Yes or no? Same Q. I can write what is A3. So I can write V4 becomes A3 by A4, V3. Correct. No problem. So V4 I can calculate. V3 I can calculate later. What is A3 and A2? Because I know the diameter. A4 diameter is 0.2 and A3 is 0.1. Right? Now I just put the value here. What I can write? Tell me. This one is pi by 4. Pi by 4, 4. A3 is 0.1, right? 0.1 square. Pi by 4, 0.2 square, right? This is V3, correct. Then V4 becomes, you can write V4 becomes 1 over 4 times V3. Correct, right? V3 by 4. Alright. Then, now I can do later Bernoulli's equation between 4 and 2. Easy. 4 and 2 I can do Bernoulli's equation. Right? And V3, how you can find V3? You have to do Bernoulli's equation between 3 and 2. Then you can calculate V3. Now 3 and 2 I can write. Then you can see P3 0, right? And P2 also 0. 0, right? V3 is not 0, but V2 is 0, right? Z3 0, but Z3 is H, correct? H I know 2.8, right? Then V3 I can write 2GH from there. Now I can do 2 times 9.8 times 2.8. So V3 becomes 7.41 meter per second. V4 becomes, you remember, right? V3 by 4, right? 7.41 by 4. I can get 1.85 meter per second. Agree? Done. Alright. Then after that I do Bernoulli's equation between point 4 and 2. Easy. If I choose here and here, two velocity, then you have to do more calculation. If you choose this one and that one, easy, because at that point V cancel, P cancel, right? But at that point only two parameters, right? And Z I know. Now what I can do now? Now I can write Bernoulli's equation between 0.4, this is 0.4, and 0.2. Then I can write, tell me, P4 I have to find, P4 by rho G, P4 square by 2G, Z4 is equivalent to P2 by rho G, V2 square by 2G plus Z2. Am I right? Then I can tell you this 0, this is 0. P4 is not equivalent to 0. So I have to consider P4 by rho G. I cannot do anything. What is V4? V4 is equivalent to 1.85, right? 1.85 square by 2G. What is Z4? Minus 1, right? Z4 is minus 1. Z2 is 2.8. Then I can write P4 rho G is equivalent to 2.8 plus 1 minus 1.85 square by 2 times 9.8. Correct. Then after that you can calculate P4, right? What is the value of rho G? You remember, right? I show you 9.8 or 9800, right? Newton per meter cube, right? This is kilonewton per meter. Then finally I get here 35.52 kilopascal. If you use 9.8 is kilopascal. If you use 9800, answer is pascal. Okay, this is the understanding. Rho G is 9.8 kilonewton per meter cube or 9800 kilonewton per meter cube, right? I teach you this long time back. Right? In my first class. Alright, this is the answer. Alright, do more practice. How to apply different statements. You want to see previous? Okay? Okay, now I am going to my last question. Last question is, I think, very simple. Is the easiest one. Same concept, right? But you try to solve the previous year exam question. You try to solve. I think Prof. Marcus he will post some previous year lectures, right?
Yeah.
So please watch all this.
This is
the last question. In my last question, so determine the water depth in upper tank HA. You have to find this value. When the flow reaches its steady condition, constant water level at the both tanks. That means water level is constant, water level is constant, doesn't change. This is the condition. Assume frictionless flow. Fine. Then I can choose the reference point here. Correct. I can choose reference point here also. No problem. So I choose this point is number 1. This is number 2. This is number 2. This is number 3. Right? This is number 4. So at P1, what is the field? P1 is equivalent to 0, right? What is the V1? V1 is also 0 because fluid is stable, right? At that point. Stable. And P2, 0, right? But V2 is not 0 because water is flowing to another tank. And at that point, P3 is 0. V3 is equivalent to 0, right? And at that point, P4 is 0, right? But V4 is not 0. So if I choose this one as reference point, right? If I choose this as reference point, I can say Z2 is equal to 0, right? And Z1 is here. So Z1 is equivalent to H. Similarly, Z3, if I choose this as reference point, Z3 is equivalent to 0 and Z4 is equivalent to 2 meter. Okay, this is the understanding. Alright, if you choose this one reference point, so this one, this height I do not know, right? So that's why it is better to choose this one as reference point. For the upper tank, this one as reference point for the lower tank. So in one question, I can choose 2 or more reference points. Okay? In that case, you should be clear about the height or elevation. So now I do my Bernoulli's equation between 3 and 4 and 1 and 2, right? From 3 and 4, I can calculate the velocity v3, right? No problem. So, there is another condition, continuity equation. Flow rate and all are same, right? The volumetric flow rate, Q, right? Same Q. So I can write same Q. Then I can write A2, B2, and A4, B4, right? Same. Correct. I can write this condition also. Okay? That is one continuity equation and Bernoulli's equation. The problem is. Now, you see, I can write steady flow here and here are same, right? Then I can write this equation and Bernoulli's equation between 3 and 4. I can write P3 by gamma, P3 square by 2g Z3, and P4 by gamma, P4 square by 2g Z4. Then you see, right? This one 0 pressure, this one 0. Here velocity is 0, but here velocity is not 0. Z3 is 0, right? No, Z3 is 2 meter, Z4 is 0. This is 0, right? And Z3 is 2 meter. This value is 2 meter. Then I can write V4 equals to 2G Z3 minus Z4, same thing, 2 meter. Then I can write 2 times 9.8 times 2, right? So V4 is equal to 6.26 meter per second, right? Then I can write Q4. What is the value of Q4? Q4 you can write pi by 4 A4 pi by 4 D4 0.05 square, right? 0.05 square. This is area times velocity 6.26. Then I can find Q4 is equivalent to 0.0123 meter cube per second. Alright? Meter cube per second, I get it. Done. No problem. Then I can easily calculate the value of V2, right? From that condition. Then I can find this is Q, right? So Q, I tell you, right? I can write A2, V2, A4, V4, right? This is Q4 means A4, V4. Then I can write 0.0123 is equivalent to pi by 4. Area is 0.03, right? Square times V4. I know the value of V4, right? Sorry, V2, I'm sorry. So this is A2, V2. This is A2, this is V2. Right? Then I can calculate the value of V2. It's okay, right? Yes or no? You can calculate. Alright? Now, I'm going to the next slide. When I do my analysis between Bernoulli's equation 1 and 2, and this is the reference line, then I can write P1 by gamma, V1 square by 2G, Z1, P2 by gamma, V2 square by 2G, Z2. Then I can cancel, right? V1 cancel, Z1 value is H1, Z2 is 0. Then I can write this value. P2 becomes this number, right? And I can write V2 becomes pi by 4, 0.3 square, 2G H, right? 2GHA. This one is equivalent to V2, right? Then I can get this. Finally, I can get. Alright? Understand? From there, I can get V2. Then I can get here, HA. Or in the previous slide, I can calculate V2. Remember, right? Another method. You substitute that value here, then you can find V2. Or A. Also, same answer. Both method you can get the same answer. Here, V2 I get from this Bernoulli's equation, 2GH and 5 by 4 H square is the property. V2 is equivalent to Q, which is 0.0123. We substitute the value, I can find 15.4 meter. This is the answer. Alright? But understanding is important. You have to understand clearly. And you have to judicially select the point. Not anyhow. If you do anyhow, in the exam hall, you cannot solve the point. So that's why you do more practice. If you solve one question, don't